Hello and welcome to this introductory lesson on Docker. In this lesson, we're going to look at what Docker is and we'll take a quick look at the internals of a machine, and I'll give you a brief insight into how application hosting has evolved over the years so that you can better appreciate the need for Docker. So, what is Docker? Docker is an open platform with an ecosystem of tools that lets you develop, ship, and run applications. Over the course of these next few lessons, we will revisit each of these blocks to actually develop, ship, and run a simple web server application so that you can experience firsthand the magic of Docker. We'll choose to build a web server using Node.js and Express, but you can imagine the same idea can be extended to any other framework or language. In order to better understand the need for Docker, let me take a quick departure from Docker and look at the internals of a machine. A machine in this context refers to anything that gives you computing power. If you take your personal computer, for example, it has hardware which provides some resources to allow programs or applications to be run on this machine. The main resources that you have at your disposal are CPU, memory, and input-output devices. Input-output devices can range from your keyboard or mouse to modems and network cards. On top of your hardware, you have your operating system, be it Windows, Mac, or Linux. And your operating system runs a program called the kernel. The kernel is the software that directly interfaces and interacts with the different hardware resources. Your operating system also runs processes for different applications like your browser, music player, terminal, notepad, etc. These different applications or processes can communicate with your kernel via system calls. A system call is merely a mechanism that the kernel provides as an interface for any application to communicate with the kernel based on a predefined contract. So, as an example, an application process may ask the kernel to create a new process with the help of these system calls. Now that you have a basic understanding of a machine, let's talk about how web applications were primarily hosted a while back. And in this case, when I say long ago, keep in mind that there are still traditional monolith applications today that run with this setup. It's simply that this is not the norm for building modern applications anymore. Companies back in those days would purchase racks in a data center or have their own on-premise data center to host their servers. Companies can have more than one application that they want to run, especially large-scale enterprises. To understand this with a simple example, imagine that you have two websites which communicate with their own API endpoints and applications. You could host both these applications on the same web server machine. This means that both these applications use a shared file system and shared resources. That is, they both take CPU, memory, storage, network, and so on from this common web server. There are a couple of issues with this approach. One has to do with performance. If the usage for one application spikes because of traffic load and it starts taking up more resources, the performance of your second application will also be affected by this spike. The second issue is that your applications are not isolated from each other and can access the other application's data, which is a bit of a security concern. So, to not run into this issue, companies would typically purchase an individual server for each application. The problem with this approach is that you can't really reuse servers with spare capacity for new applications, and you had to sustain exorbitant costs because new applications meant new servers. And you had to purchase powerful servers that could handle the peak expected traffic for your application, even if your server goes underutilized most of the time. Then came this idea of virtualization, where you could run a piece of software called a hypervisor. And what this does is it separates resources from their physical machines so that they can be partitioned into virtual machines. Each virtual machine would run its own operating system within its partition, and you could run your application in isolation on top of these guest operating systems. The problem with virtualization is that VMs are pretty heavy because they come with their own guest operating system, which takes up a sizable amount of resources. And furthermore, they take time to boot, and each OS will need patching and monitoring over time. To overcome the limitations of virtual machines, companies started using container based technologies. A container is an isolated, lightweight silo for running an application on the host operating system. Containers don't contain full blown operating systems, but rather contain only the application and the dependencies that are explicitly needed to run this application. Since containers come self packaged with their own runtime, you do not need to worry about whether something is installed on your host operating system or not. Because containers are lightweight and fast, you can run several containers on a host operating system to dynamically manage workloads. So, if your demand increases, you simply add more containers to handle it. When the demand goes down, you can remove containers, and in this way, you can scale your compute capacity to achieve your business goals. That's it for this lesson. In the next lesson, we will start looking at Docker in practice and get our hands dirty and actually build our own container. Thank you.